Okay, we're up and running for Concept Worksheet 203 SAT. This video is specific to the SAT. So sometimes I have students who get problems, and the problems deal with kind of second-tier algebra stuff. And the students say, I saw this problem, I had no idea what it wanted from me, or I had no idea what it was asking me. Well, if you feel like you've seen kind of an algebra type problem before and you just didn't know what it was getting at, chances are it's contained in this worksheet. And the explanation falls into one of these problem types, whether it's using quadratic formula, whether it's understanding what the discriminant is, whether it's just being familiar with the three common quadratics. And the other big one is matching coefficients. We are going to skip over the polynomials part in the beginning. Problems 1 to 18, because I think that's something most people are going to be familiar with, and you can always read through the notes that are already contained on the worksheet. But we are going to go through these other 4 topics here, and I'll make sure that you understand how they apply to the test and what the test wants from you as it pertains to each one. So with no further ado, I do think it'll take a little bit to get through these. Probably this video will probably end up being close to somewhere between 20 and 30 minutes. So let's get going. So anyway, first concept is quadratic formula, which should be familiar to pretty much everyone watching this video. It's something you would have needed for GCSEs. The thing is this, I bet half the people watching this video have it memorized and half probably don't. For this test, you do need to know it, because on section 3, the non-calculator section, you do get problems sometimes that expect you to know quadratic formula. What is quadratic formula? Well, quadratic formula, first off, it gets you your x-intercepts. So it tells you where you're going to cross the x-axis. The test will refer to x-intercepts as zeros, meaning your value for x when your y is 0. The test will also call them roots or solutions. So all 3 of these, they all mean x-intercepts as well. So don't allow the terminology to trip you up on the problem. But anyway, you need to first have a quadratic. So an x squared is your highest degree indice or exponent. And in the quadratic, it needs to be in standard form, ax squared plus bx plus c form. Okay, so that's required before you can even use quadratic formula. But when would you use it? You would use quadratic formula maybe on a problem like this one. So this problem, these are your x-intercepts. There's no way we could factor this to get those. It's just not really feasible. So what do we do instead? Well, we just put it into quadratic formula. And what you may notice is with that coefficient of 2 in front, that also makes this a little bit more difficult to try to factor by hand. So sometimes if you have a coefficient other than 1 in front, you may just want to go straight to quadratic formula. There are other options, but you can always go to quadratic formula. That will always get your x-intercepts. So what is quadratic formula? Well, it's negative b. I try to break it up like the test does. Negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. You do need to commit that to memory. You could sing it to yourself. You can repeat it again and again. You can write it a million times, but you do need to have that down for the test. So in the case of this problem right here, the opposite of b is negative 5 plus or minus the square root of 5 squared minus 4. A is 2. C is negative 9 all over 2 times a, 2. Solving that gets you your 2 x-intercepts. So let's see why you would need this on the test. I'm actually going to skip this problem, and I'm going to go to this one because this problem's a bit more intriguing here. So essentially what we have here, if we were to rearrange these, is so we have the opposite of y equals the opposite of x plus 1. So that means this top equation really becomes y equals x minus 1. So that's our linear. Then what we have with this one is we have y equals x squared minus x minus 3. So these are our 2 equations. We have a quadratic and we have a linear equation. And it wants to know an ordered pair, so it wants to know your x and y to your answer, to one of your answer choices. So this is really interesting. What this would look like if we graphed it real quick drop down 1 to -1, and then rise over run is just 1 over 1. So we have this line. We have this quadratic that opens up. There's a way to figure out where the vertex is, -b over 2a, if you're familiar with that. If not, don't worry about it. It's covered on another video. But anyway, we're going to have this quadratic that's going to open up, and it's going to cross this line in 2 places, and we need to figure out one of the 2 places where they cross. So how do we go about doing this? Well, the thing is this. What we do is we have both of these equations. We've set them equal to y. Now we can set them equal to one another to figure out what x is when they're equal to one another, when they cross. So we have x minus 1 equals x squared minus x minus 3. Move everything over to one side. So 0 equals x squared minus 2x minus 2. And what you'll notice is this isn't really favorable to factoring here. We're kind of stuck if we try to factor it. We don't have any 2 terms that multiply to -2 and then also add to -2. So we'll use quadratic formula, and we can kind of have a hint that we're going to end up using quadratic formula because our answer choices contain plus a root. So we can kind of tell if we have plus a root that that's going to come from quadratic formula, plus or minus the square root of something. So anyway, if we put this into quadratic formula real fast, and again, we'll go -b, so that's going to be 2, over 2a, so that's 2 times 1, right? Your a is 1, plus or minus b squared, which is going to be -2 squared, minus 4 times a, which is 1, times c, which is -2, all of that over 2a, which is 2 times 1. Okay. What we notice immediately is out front we have 1. That already makes me think that our x value is probably going to be either a or c. So I'm already hedging towards those as my answer choices for where these cross. Okay, I'm going to do some purple so it stands out. So what we have left over is 4 plus 8 here, right? So that's going to give us root 12 over 2. And if we just move this over, root 12, we have a 3 and a 4. A 4 is 2 2's, so we have 2 root 3. So we have 1 plus or minus 2 root 3 over 2. That cancels out, so we have 1 plus or minus root 3. So that tells us that we're looking at a. That's our x. And if we were to plug this in for x, we would get root 3 for our y. So that's the way to do this with quadratic formula. The reason why I chose this problem, though, is on a lot of problems, there are multiple ways to get them. And sometimes it's important to take a deep breath if you're not sure what to do, to just kind of open your mind and be willing to think laterally. So here's another way you could do this problem. Because these all represent x and y values, if you weren't sure what to do, you could just plug these in to the equations and just see which one makes both equations balance. So if we go up to this top one, we have 1 plus root 3 for x minus root 3 for y, and that has to equal 1. Well, guess what? Root 3 minus root 3, we get 1 equals 1. So already, with plugging this in, the top equation works. We just have to check and make sure the second equation works. So let's do that right now. So we have 1 plus root 3 for our x out front on the second equation right here. Oh, that looks like a minus. Let me get rid of that. Okay. And then what we have here is plus y. So it's saying our y is root 3 equals x squared. So 1 plus root 3 squared minus 3. And I know what you're thinking. You're probably thinking, I won't have time to do this on the test. Well, maybe you skip this problem and come back to it, but it's better to have a way to try to get it right than to just completely give it away. Anyway, what we get on the left side is 1 plus 2 root 3. What we get on the right side is 1 plus 2 root 3 plus 3 when we do 1 plus root 3 times 1 plus root 3. If you FOIL it, if you do all the multiplication there, that's what this will get you. And then minus 3. Well, guess what we end up getting? The minus 3's cancel out. So we end up getting 1 plus 2 root 3 is equal to 1 plus 2 root 3. And that's another way we would know that A is correct. So anyway, that's that's quadratic formula. It gets you your x-intercepts. And then also another way to kind of get around quadratic formula on that problem. But you do want to have quadratic formula memorized. And you want to know that if you're going to use it, you have to have your equation, your quadratic set up in standard form, ax squared plus bx plus c. Okay. So another kind of darling or favorite of the test is when you have two equations or expressions, sorry, not equations, two expressions that are say equal to one another, and they start to ask you about the constants or the coefficients. So first off, let me kind of define what a constant and a coefficient is. So on this problem, the 4 is a coefficient. Any number in front, and the a is also a coefficient. Any number in front of a variable that doesn't change, or in this case a, which is we're gonna figure out what number it is, but it's a number that doesn't change. Those are referred to as coefficients. Plus 5, that 5 is a constant. So any number by itself is referred to as a constant. And then the x is just your input variables. Can change. You can put in whatever you want for x and see what you get out. But anyway, that's what constant and coefficient means. So it's saying this expression above is equivalent to this. What is the value of a? So we can't begin to compare these until we put them both in the same form. So I'm going to put this into standard form. So if we multiply this out, we end up with 4x squared. That's plus 10x plus 2x plus 5. So really what we have here is 4x squared plus 12x plus 5 equals 4x squared plus ax plus 5. So they want to know what's the value of a. Well, the b term, right, ax squared plus bx plus c in standard form, plus bx plus c. The b term for both of these is going to have to be 12. So a is 12. So that's simple enough. Let me show you a problem that takes us up a level. So here's a problem from one of the first tests of the SAT back in 2016 when the test changed its form. That gives a lot of people difficulty. So I'll take a moment to read it, and then we'll just get right into it. And if you want to try it, feel free to pause the video and give it a shot. Just because I'm moving along doesn't mean you have to. You can pause at any point. So anyway, it says, in the expression above, a, b, c, and d are non-zero constants, and AD is equivalent to BC. AC is 18, BD is 50. What is the value of the coefficient of the xy term when the expression is multiplied out and like terms collected? Okay, so there's a lot on our plate there, but we might as well get it started by multiplying out the expression, collecting like terms, and seeing how this applies. So if we start to multiply this out, we're going to have acx squared, right? When we multiply ax by cx, we multiply ax by negative dy, and we're going to get minus a dyx, okay? And then we'll get plus bycx. I always try to put the x at the back because the x is your variable. And then last but not least, by times negative dy is going to give us bdy squared, so minus bdy squared. Okay. And again, what it wants to know what is the coefficient, so the number in front of your xy term. So this and this, we can really rewrite this, minus ad xy plus bcxy. I'm just moving the variables around. So it essentially wants to know what is negative AD plus BC. When we add those together, what do we get in front of XY? That's what it's asking in a nutshell. All right, well, let's figure it out. So first thing is it tells us AC is 18. So that helps remove some of the clutter. We have 18 right there. It tells us that BD is 50. So back here we have minus 50y squared. So again, helps just to have some numbers in. And then here's the key thing, and this is a moment of truth. It tells us AD is equal to BC. So what we have in the middle is we have minus AD yx plus BC yx. And we know that AD is equal to BC. Well, if AD is equal to BC, if I have AD y-axis and I have BC y-axis and one's negative and one's positive, they're going to cancel each other out if they're equal to one another, right? If this, say this were 5, well, then this would have to be 5. Negative 5 plus 5 means we'd have 0 y-axis. So in the end, we would have 18x squared plus 0 yx. So that's the coefficient in front of that term, minus 50y squared. So in this case, what's the coefficient when everything's multiplied and like terms are collected? The coefficient would be 0. A lot of good challenging problems on this section, but we need to march on. So the SAT absolutely loves the 3 common quadratics. You should be familiar with these. I would imagine they played some role in GCSE. You can take a moment to look at them here. One is difference of squares. The other is a perfect square with plus. The other one's a perfect square with minus. So it's interesting. This example problem, there are 2 ways to do it. I'm going to show you the front door, which is an easy way with recognizing quadratics. And then I'm going to show you the back door, which is just a way to get around everything. So first, let's take the front door. So if we look at these, the interesting thing about this is if we recognize it, this can be rewritten as x minus 2y squared. I don't know if you'd catch that or not, but that's kind of playing off of this third one. Okay, so now that we know that, if we look at this top one, if we divide everything by 3, we'll have x minus 2y equals 3z. Okay. So now that we have that, everything seems to line up perfectly now. But again, it was entirely dependent on you recognizing those first 2 steps, really recognizing that this is a perfect square. But once we have that, this becomes really easy. They want to know what this is in terms of z. So now we can drop in or use substitution to put in 3z for the x minus 2y term. And once we do that, we get 9z squared. Okay. So it's good to know these, and it's good to be able to recognize them, but I will show you a back door. Whenever they ask which 2 expressions are equivalent, and you're not sure how to go about it, you can always just plug in numbers. You can always take the variables and just try out numbers. On this one, we'll have to try to be wise about it. I think I'm going to make x 10. You'll see why in a second. I avoid using 0 and 1. By the way, if you want more on this plug idea that I'm going to show you, it's on plug worksheet 215. But anyway, I'm going to make x 10. I'm going to make y 2. And I don't like to make variables the same, but in this case, I'm going to make z 2 as well. Why? Because that allows everything to balance here. If I do 3 times 10, I get 30. Minus 6 times 2, that means that this whole side is equal to 18, which means that z would have to be 2. So essentially, these are 3 integers that allow me to balance this equation. So that's the first thing you have to do. Now that you have those, you can just plug them into the expression. So if we plug these into the expression, we have 10 squared, which is 100, minus 4 times 10, which is 40, times 2, right? Y is 2, so that's 80. Y squared is going to be 4 times 4 is 16. So what we end up with here is 100 minus 80, 20, plus 16, 36. Now what we do is the final piece. So we know that if we plug in these values into this expression, we output a 36. So these same values, when plugged into an equivalent expression, should also output a 36. So 9 times z, 2 is 18. That's not a match because it's not the same expression. Z squared is 4 times 3 is 12. That's not a match. I know we already know it's C, but let's just go down to D. Z squared is 4 times 81. We're going to way overshoot 36. But Z squared, 2 squared is 4. 4 times 9 is 36. The outputs match with the same inputs because it's the same expression. So anyway, that's this idea of matching coefficients. Or not matching coefficients, sorry, difference of squares and plug. So here's a difference of squares problem where we just want to know exactly how to go about it, and wants to know what's the value of this. Well, interestingly enough, if you know that x squared minus y squared equals x plus y times x minus y, then you got this problem solved, right? It's just going to be 13 times 2, which means that your answer is going to be 26. But you have to recognize that common quadratic. All right, final thing on the worksheet is the discriminant. How often does this come up? Not often. You'll be asked about the discriminant maybe once every 3 SATs, but I would hate for you to just have to give this problem away. So if you remember earlier, we want to know the quadratic formula so that we can figure out our x-intercepts out of standard form. Why else is the quadratic formula important? Well, this part that I'm going to highlight in yellow, this part under the radical, this b squared minus 4ac, this is referred to as the discriminant. What does it allow you to discriminate or kind of differentiate between? It allows you to determine how many times you cross the x-axis or how many times a line crosses your quadratic. In this case, it's 0. But anyway, think about it this way. If this number is positive, so if b squared minus 4ac, if that is greater than 0, you're going to have 2 solutions. What do I mean by that? Well, think about it this way. One of your solutions for x is going to be negative b over 2a plus this positive value of b squared minus 4ac divided by 2a. The other solution is going to be this whole thing again, except minus that value, right? Minus this whole value. So anyway, if this is positive, then we have 2 solutions. We have 2 x-intercepts for a quadratic. If b squared minus 4ac equals 0, and you can pause the video to take a second to think about what that may mean, but I'll just tell you, if you haven't paused, that means you have 1 solution, right? Your 1 solution is going to be negative b over 2a, right? Because if this is 0, if what's under the radical is 0, then 0 divided by 2a is 0. So the only value for x is going to be the part out front, negative b over 2a. If b squared minus 4ac is less than 0, then we don't have any solutions, roots or x-intercepts. We just don't cross the x-axis, okay? So essentially, how do we know when to use this? If a question asks you not what your solutions are, not what your x-intercepts are, and I want to make this really clear, it doesn't ask you what your solutions are, does not ask you what your x-intercepts are, but asks you how many you have. That's when you know immediately, oh, I don't need to figure out what they are. I just need to use the discriminant, this b squared minus 4ac, to determine how many I have. This is all explained in more detail here. So here's an example of when your b squared minus 4ac is less than 0, is this quadratic. What does it look like? No x-intercepts. Here's a quadratic where it's actually a perfect square. So we only have negative 3 is the only spot that we touch the x-axis. And if you were to put it into b squared minus 4ac, you'd end up getting 36 minus 36. You'd end up getting 0. So by getting 0, you know you have 1 solution. And then this final one, this one, if we did it, 9 minus 8 gets us 1. 1 is greater than 0 because b squared minus 4ac is greater than 0. We're going to have 2 solutions. Okay, final part of this packet. Let's look at this problem and see how we'll do it. and we're going to use the discriminant. So it says, in the system of equations above, and by the way, one of these problems is an x squared, which tells us that we're looking at a quadratic. So, you know, we could be using quadratic formula or the discriminant. So anyway, in the system of equations above, k is a constant. When the equations are graphed in the xy plane, the graphs intersect at exactly 2 points. Pause for a second and think about what that means as far as b squared minus 4ac. Does that mean that's going to be greater than 0, less than 0, or equal to 0? Well, if we have two solutions for our line and our parabola, right? If we have two solutions, then that means that when we do the opposite of b over 2a plus or minus the root of b squared minus 4ac all over 2a, to have two solutions for x, that means this has to be positive. We have to have negative b over 2a plus whatever this whole thing is, and negative b over 2a minus whatever this whole thing is. So the radical would have to be positive, or what's under the radical. So anyway, b squared minus 4ac has to be greater than 0. Okay. And so which of these cannot be the value of k? So which of these, if it were k, b squared minus 4ac would not be greater than 0? We would not have two solutions. So the first thing we're going to do is we're going to use substitution, where we're going to plug in this for the y of the linear equation. So what we have is we have kx, okay, plus the quantity of negative x squared plus k equals 1. All we did is we just subbed that in for that. So now if we kind of rearrange this into a much more friendly form, and I'm going to put everything to the right side, we have 0 equals x squared minus kx, right, plus k, or minus k, plus 1. Okay. Our a term is 1, right? It's an implied 1. Our b term is negative k, right? Ax squared plus bx plus c. So our a term is 1, our b term is negative k. This entire thing is our c term because there's no x. So this is just a pair of constants that create our c term. Okay, so anyway, we want to figure out b squared minus 4ac has to be greater than 0 to have two solutions. So if we're using this equation here, what we know is this. We know that negative k squared minus 4, a is 1, and c is k, negative k plus 1. This whole thing has to be greater than 0. So if we quickly simplify it, we have k squared plus 4k minus 4 has to be greater than 0. If we put in a 3, so I'll just start at the top. If we put in a 3, we're going to end up with 9 plus 12, right? So 21 minus 4. 17 is greater than 0. So A would work, but if you read this carefully, we want to know what K cannot be. So if we put in 3 for K, it would work. So I'm going to skip all the way down to D because that's the answer, and I'm just going to show you how D plays out. If K is 0, we would have 0 squared plus 4 times 0 minus 4, and it's trying to tell us that negative 4 is greater than 0, which it isn't. So if we end up getting a negative here from on our discriminant, our negative or b squared minus 4ac, then that tells us immediately we don't have any solutions. If we're supposed to have exactly 2 solutions or 2 points where the line and the quadratic cross, then k just cannot be 0. Okay. Anyway, thank you for being patient with the video. Hopefully that sets you up for these concepts. As I said at the beginning, these tend to be the algebra concepts that students see on the test and they feel very uncertain about. So if you go through this packet, hopefully when these problems come up, you'll know exactly what the test wants from you. Good luck.